this is part 2 of our rates series of vlogs. And if you remember in the last series, we looked at rates and we looked at the different experiments you could do to measure the rate of reaction and how you could measure the rate by either following the decrease in the reactant or the build-up in the product. Now, Miss McLaren and I have done 2 experiments. You can see one here and one here, both of which have a gaseous product, but the graphs we drew were of 2 different shapes. Now, Miss McLaren, are you able to explain why the graph for this experiment is of this shape, but the graph for this experiment, which is also a gaseous product, is of this shape?
I think I'll try. If I get any problems, Dr. Bone, can you help me?
I will.
Right, so we'll look at this, and we've got magnesium chloride and hydrogen, so I suspect we're going to be measuring the volume of hydrogen produced.
Correct.
Per minute. So we would use this apparatus.
Right, and I see you've got a syringe in your lovely diagram there. Why are you using a syringe?
Well, because we have to measure the volume of gas,
right, and
that would have to be measured in cm cubed.
Right.
So we need a graduated gas syringe to measure
something with a
volume.
measuring. Right, perfect, lovely. What else would you also need? Another piece of equipment that you haven't drawn.
Well, I did actually purposely leave out the stopwatch because although you can say I'm very artistic, but I'm not that artistic. So stopwatch.
Great. Okay, lovely. So, let's have a look at this one then. So we're also, you've got a gaseous product, but this time the graph is of the opposite direction.
No, there's a reason for that, Dr. Bone. I think I might be able to figure this one out.
Yeah.
If you look at the reaction going on, that carbon dioxide is escaping. So if we measure the mass of the reactants, and eventually it will be the mass of the mixture of reactants and products, then I presume the gas is escaping, which means initially that's the mass of all your reactants.
Yes.
As the gas escapes, the mass decreases.
Yes.
Because gas has mass, Dr. Bone, is that correct?
That's absolutely right.
Which means we have this style of curve going down.
Perfect. So this is done on a balance. And why do you think cotton wool was chosen to be the stopper in the conical flask?
Well, you wouldn't use a stopper because if you're getting a gas building up, you get a build-up of pressure, and we don't want that.
No.
But the cotton will allow the gas to escape, and also it will actually possibly allow to ensure that no acid is sprayed, which means we lose acid, which means we get the wrong results. Is that correct?
Absolutely right. Now, while we're just on the subject of the acid and the cotton wool and possible escape, how would you protect yourself? What safety precautions should you be doing while you're doing this experiment?
Well, if you're using acid, we always wear safety goggles.
Very good.
We actually use our knuckles.
Yes, excellent. Very good indeed. Right, now, so we've sorted that little problem out. Let's have a look. What else do we need to decide about? Right, let's take the shape of these graphs. Where do you think, looking at that graph, the rate of reaction is the fastest?
Right, so this graph, I would say it's the steepest curve. So that section would be the fastest rate.
Lovely. So wherever the graph is most steep, that's the fastest rate. And that's always going to be at the
very beginning.
The very beginning. So not up here, right at the beginning. Then what happens next? Where does it...
Well, the steepness of the curve reduces. So it's starting to slow down.
Yep.
At this stage. Is that correct, Dr.
Yes, absolutely right.
You're doing well.
So here it's slowing down, but here I see the graph has plateaued. So what has actually happened? As time's going on...
Well, I can see there's no more gas being given off, so I presume it has actually finished.
Yes.
So it's finished here.
Right. And when did the reaction actually finish?
Well, when it starts to level off.
As soon as it starts to level off.
About here?
Yes. Lovely. Perfect.
Great.
And why did the reaction finish?
Well, it must be because one of those reactants has been completely used up.
Very good. Now, does it have to be one, or could it be both, or is it both, or...
Well, generally you might have one that's in excess. So if you have excess acid, then it means it would be when all the magnesium is used up.
Because there's no more magnesium to react.
So therefore no more hydrogen is produced.
Perfect. Right, now let's have that interpretation again, but for this graph.
So at the very beginning, the rate of reaction is going to be the fastest.
Fastest, good.
And then that's a less steep curve.
Yeah,
So
absolutely
we're
right.
starting to slow
I
down.
think you've got the hang of this now.
And
And here?
And here is starting to level off.
Yeah.
So that means no more gas has been lost, which means the mass remains constant.
And at which point does it actually finish?
I'm going to try this, see if I get it right.
Yeah.
So be about there.
Very good. As soon as it levelled off. So that was when, what?
When one of the reactants has been used up.
When one of the reactants has been. It's very, very straightforward. Rates are very straightforward once you get the hang of them.
Dr.
So,
Bond, can I
have you got any questions?
Yes, so does that mean I can work out the exact time that the reaction's finished using the graph?
Yes, you can. Now, how might you do that? If you know this is the point, how would you know?
Then I would actually
Take it down to there.
take it down there.
Read it off this axis.
So I would do exactly the same.
Yeah.
Read it down there.
Yeah, wonderful.
Wow.
I think you've learnt a lot there, Miss McCarran, but not only you. I heard another contributor.
I think Kiki loved
Loved
rates.
it and learnt a lot
Yes.
about our rates.
So easy peasy,
Lemon
lemon squeezy.
squeezy.